The SCY-Dynamic tools is used for creating dynamic, graph-based models of complex problems and phenomena. It can be used for building models and running experiments to test hypotheses or to generate data for later analysis. SCY-Dynamics is based on language for representing systems that are dynamic or change over time. The basic elements of the language are stocks, which can be either declarative or accumulative, and flows between the stocks. This makes it possible to illustrate and study how systems behave over time. You open an existing dynamic model by clicking the icon in the activity space. This is a model of how a bacterial population changes exponentially over time, affected by a number of births and deaths. The toolbar on the left side contains a pointer that is used for selecting objects, editing, and moving the objects. Under the pointer icon is a symbol for a stock. Stocks are the basic elements in a model. The circle represents an auxiliary. You use auxiliaries to calculate values and feed them into other nodes. The diamond-shaped button underneath represents a constant. A constant is a node used to store fixed values in a model. A flow, represented by the thick arrow, is a link between stocks and is used for adding or subtracting the change over time from stocks. The thin arrow represents a relation. A relation is a link between any two nodes and is used for making variable values or quantities known to other nodes. The set of icons below the model elements are editing tools, which are used to delete, cut, copy, and paste in the model. There are 3 tabs in the top of the window: Editor, Graph, and Table. In the Editor tab, you create and work with the model. Graph and Table are used to visualizing the results created by running your model. The example model here shows a stock of bacteria. If you double-click it, you see that the population is set to 1,000. The unit type is set to items. It has a flow into it, which is bacteria, and a flow out of it, which also are bacteria. The auxiliaries, births and deaths, flow into and out of the population. Birth contains expression population times birth rate, and death contains expression population times death rate. The constant birth rate and death rate have been set to 0.2 and 0.1 respectively. Now we can run the model and see how a population of bacteria grows exponentially over time. Under the Graph tab, the results of running the model are visualized as a graph. First, select the variable or variables for which you want to see the results. Let's choose population. The start time, stop time, and type of time also need to be set, if it has not been done already. The vertical axis in the graph represents the number of bacteria, and the horizontal axis represents time. Click on the arrow to run the simulation. The points on the graph represent the number of bacteria, and we see how it increases exponentially. We can also include the variables births and deaths and see how these will change over time. The color of the graph line is the same as the color associated with each variable listed in the box. Change to the table graph to have the same results displayed as values in a table. To save the results from running your model and use them with other tools in SCY-Lab, click the icon for Save Copy AV-ELO as Dataset and enter a title for the dataset in the window that appears.